Alright, let's continue our study of logarithmic functions and by connection exponential functions. In this video we will focus on finding the inverse of logarithmic and exponential functions. We will solve an inequality, a couple of logarithmic and exponential inequalities, and that's probably it. So, number 7. Alright, there are two steps to solving, to finding the inverse of any function. Step 1 is to switch x and y, and step 2 is solve for y. So what am I talking about? Well, this k of x part is basically like a y. So when I say switch x and y, I mean let's put x here and let's put y here. Okay, so now we have switched x and y. Now we just need to solve for y. Well, first let's get rid of this extra plus 2 hanging around by subtracting 2 from both sides. Alright, so that's going to give us, so far, x minus 2 is equal to natural log 3y minus 1. Okay, so that's as far as we can go algebraically. Now we need to rewrite this in exponential form to get the y out of here. So it's useful to understand that though we would never write this down, natural log is the same thing as log base e. So this would be an equivalent expression. But writing it this way helps us see what we need to do next. When we rewrite something in exponential form, we start with the base. So log base e. E is the base, so let's start there. Now everything else in the problem is going to change sides. So these two expressions are going to change sides of the equation. So my 3y minus 1 is going to end up on the left. The x minus 2 is going to end up on the right, but in exponential form, it's the exponent. So we have this. Now, remember, our two steps were switch x and y, and then solve for y. So we're trying to get y by itself. So here we have two more steps of algebra to do. So we're going to add 1 to both sides of the equation. Okay, so that's going to give me now 3y is equal to e to the x minus 2 power plus 1. So last step to get y by itself, we need to get rid of this 3 by dividing both sides of the equation by 3. Okay, so we will have y equals e to the x minus 2 plus 1 over 3. Now, instead of putting y, we need to go back to what we started with. Okay, we had k of x. Now, I can't call this k of x, alright, because that's already defined. So, we will call it k inverse of x by putting that little minus 1 on it. And that is the inverse. Oh, okay, they had a nice spot for us to put it down here. Alright, number 8. We need to find the inverse of this function. So once again, we need to switch x and y and solve for y. So this is like y. So when I say switch x and y, we're going to put the x here, and we'll put the y here. Alright, so we switched x and y, now we need to solve for y. So first we have an algebra step. Add 1 to both sides. So that's going to give us x plus 1 is equal to 10 to the 3y power. Now, in order to get y out of the exponent, we need to rewrite this in log form. So when we rewrite something in log form, you start with the base, and it will become log base, whatever that base is. So this would be log base 10. Now everything else, the x plus 1 and the 3y, these things are going to switch sides of the equation. So the 3y is going to come over here, and the x plus 1 is going to come over here. Okay, now because it's a sum, it's a binomial, you really need to put this in parentheses. Alright, if I just wrote log of x plus 1, it would only be the log of x with an extra 1 added on later. So you have to put it in parentheses to show that it's the log of the x and the plus 1. Now this is probably bothering you because you know that we don't write log base 10 like that. Okay, the 10 is understood, so we can go ahead and erase that right now. So we'll just write log x plus 1 instead. It's understood. It's called the common log. Now the last step, another step of algebra, is to just divide both sides by 3. Okay, and that's really going to give us the final answer right here. I'll just recopy it nicely on the line they provide for us. So this is going to be log x plus 1 over 3. Alright, for number 9, we need to solve the inequality below algebraically. And then we're going to graph and shade the solutions on a number line. And we're going to write our final answer in interval notation. So, how do we solve an exponential inequality? Well, what we start off with is finding what we call a critical value by looking at the version of this as though it were an equation instead of an inequality. So let's temporarily set this aside and look at the equation 3 to the x minus 2 power equals 27. Now this is not the same thing, but this will give us a critical value that we will use. So how would I solve this equation? Well, I notice that my variable is in the exponent, and whenever that happens, logarithms are my best friend because logarithms are exponents. So let's rewrite this in logarithmic form. In log form, you start with the base and you write log and then that base. So the base is 3, so this will become log base 3. Now, the rest of this is going to change sides of the equation. So the x minus 2 and the 27 are going to wind up on opposite sides from where they are now. So the 27 will come over here, and the x minus 2 is going to come over here. Alright, so we're closer to having x by itself. Now remember, this is, we're not allowed to use our TI-30XS multiview. So don't get any funny ideas. We're going to have to be able to do this from the dome, alright, using our brains. Now, that's not going to be hard to do because if you understand what a logarithm is, then you're thinking to yourself, okay, the log is the exponent that's going to change this number into this number. So in other words, 3 to what power is 27? And hopefully you know that that's 3 to the third power. So right away, that's the value of that expression, is 3. Okay, if you have access to an exponent table, you can check it out. 3 to the third power is 27. Okay, so getting this x by itself is trivial. Add 2 to both sides, so we get 5. Okay, so that's simply a critical value that we're going to use. So let's go to the number line, Batman. So here we have our critical value of 5. Alright, I'm leaving a little space because I often like to involve 0 in this. So here's 0 over here somewhere. But anyway, back to the 5. Let's put a mark there. Now, is this going to be an open circle or a closed circle? All right. Well, ultimately, we want to find the values of x that will cause this expression to be greater than or equal to 27. So we want to include anything that makes it equal to 27. And that's what we just solved. So this value, this critical value, is what makes it equal to 27. So we want to include that, so we'll show that by making it a closed circle. So the rest of the solutions will either go to the left from here or to the right from here. So what we need to do is do a test value. A convenient value to use is often 0, is a convenient one to try out. So let's check 0. If 0 is a solution to the inequality, then everything on the left will be a solution. If it's not, then everything to the right must be where the solutions are. So let's check 0. Okay, so we're going to check an x value of 0. So looking at the original inequality, that would give us 3 to the, now if x is 0, then all we really have is -2. Okay, is greater than or equal to 27. Alright, so we're trying to figure out, is this a solution? Alright, is this a true statement? Well, remember, a negative power here, all that does is it drops you down. So this would be 1 over 3 squared. Alright, we already see that this is not true. This is going to be 1/9. Alright, is 1/9 greater than or equal to 27? No, it is not. Okay, so that means 0 is not a solution. That means none of these values over here on the left are solutions. That means the solutions must be over here on the right, like this. So this is the solution set. Alright, so if I write that in interval notation, it would look like this. I'll have to use a square bracket to show that we're including the 5, just like we did with a closed circle. And then we'll do from 5 to infinity. 5 to infinity. Infinity always gets the round parenthesis. And that's it. That's the solution to this inequality. Alright, so that was number 9. Now, how about number 10? Now, if your teacher is foolish enough to give you the graph to go with it, then this should be trivial. Okay? It would take a little bit of thought to solve this if we didn't have the graph. But given the graph, come on. Come on. Now, here's one thing, though, that you have to be careful of. Logarithms cannot be negative. You can't take the log of a negative number. So there's going to be an asymptote over here. Now, looking at the graph, it's not 100% obvious. But if you look here, hopefully you understand that if you have a +4 in here, that's a shift to the left 4. Now normally a logarithmic function has a vertical asymptote right here. The y-axis is normally the asymptote. And again, that's because you can't take the log of 0 or a negative number. So it makes sense that the graph curves and does not reach that 0, right? It's not defined anywhere over here to the left. But this graph is being shifted to the left 4, so that is an extra little wrinkle, but it's nothing that's going to bother us. We just understand that now the asymptote will be over here, vertical asymptote at -4. So there you go. Just keep that vertical asymptote in mind as you do the problem. This graph does not go to the left forever. It doesn't go past -4. It doesn't reach -4. Okay, so now let's do the problem. We want to know where the function is less than or equal to 2. Get this out of the way for a second. Now here's the key. Above or below. When you look at this symbol right here, okay, less than or equal to, are you thinking graphically above or below 2? Well, if we want less than or equal to 2, then we want values that are below 2 or equal to 2. Okay, so it's all focus on the word below. Now, see this red line? See how it's at 2? Well, there you go. That's the 2 that we're talking about. All right, and we want to know for what x values, you know, where horizontally is the graph below 2, below this red line. All right, so well, looking at the function shown here in blue, you can very easily see that this is the part of the function that is below the 2. All right, not this part up here, this part down here. So we can just look at the graph and see the solution set right from there. The x values go from where to where? Well, I even gave you the ordered pair right here, 5, 2. All right, the 5 is the coordinate of this spot right here. This is 5. All right, of course the y value 2 is just the height of this point. All right, but as far as x values, it ends at 5. Okay, now going to the left, remember, does this thing go forever? No, it only goes as far as -4, and it doesn't even reach -4. So what x values, because that's what we're solving for, is x. The x values that will make this function below 2 are these yellow x values here that go from -4 to 5. So on our number line, we can just easily graph that. Okay, so here's -4 and here's 5. So the solution set is going to go from -4 to 5. Okay. Now, are these going to be open circles or closed circles? That's a little crooked. All right, you're going to let me slide on that. Now, the -4 is definitely going to stay an open circle because this, remember, is the asymptote. And you never reach the asymptote. It never can be -4. Okay, so we're going to leave that out as an open circle. What about this? Will this be an open circle or a closed circle? Well, let's see. We want the values that will make the function less than or equal to 2. Okay, right at 5 we are equal to 2, and we want to include that because it says or equal to 2. So we will make that a closed circle. So on a number line, that's how you would graph that solution set. Using interval notation, we would say round, parenthesis, -4. All right, the round is the same as an open circle. And we will say a square bracket on the 5 because the square bracket means the same thing as a closed circle, including the 5, not including the -4, everything in between. So that is it. Okay, that's how you do number 10. And I think that was the last problem on this page. Alright, so that's going to be a convenient place to stop this video. Alright, now we have 2 more pages to go. So on the next video, we get to take out our TI-30 XS multiview, and we will go ahead and solve some equations involving exponential functions and logarithms. We're going to solve some equations. And Oh, and here, and at the very end, maybe we'll get into some word problems, but maybe I'll save that and do all the word problems on the other video. Anyway, so in the next video, we're going to solve some logarithmic and exponential equations. And we get to use our TI-30 XS multiview. So I'll see you on the next video.